Okay, so everyone, this was what we did last class. If you have solved it already, then we can discuss the answers of them. And otherwise, today we'll do some number theory and some algebra questions. I mean, we'll do some assortment of questions, mostly number theory. Uh, and do you guys remember doing these questions? I'll anyway solve them in 2 minutes.
Yes,
But
sir.
uh, just take a look at them.
Hi sir, what will we be doing today?
Number theory or some algebra, some assortment questions.
Okay.
अरे अभी बात कर सकते हो आप.
Just a minute, I'll start. Okay, so this question 1, question 13. This is quite easy to solve. This will be, we can factorize this over here as xy, x plus y plus x plus y equal to 63. And then this will be x plus y times xy plus 1 equal to 7 times 9. Okay, 7 times 9, because 63 is 7 times 9. And this thing is 7 because xy is 6, so xy plus 1 is 7. And x plus y equal to 9. Xy equal to 6. From these two equations, you can like square this and remove 2xy. So 81 minus 12 will be 16. So this is the answer. Those who got 69, very good. Sorry. This question 14. You can assume that this is equal to some number, let's say alpha. Okay, the next step will be to multiply by C. So we have ay minus bx upon c is equal to alpha. What I do, I'll multiply this by c square and c square over here. Okay. Same way for cx minus az upon b, I'll multiply both sides by b square equal to alpha b square. And over here, bz minus cy upon a, we multiply both sides by a square, alpha a square. And now over here, 1c, 1b, 1a will get cancelled off. And what I'll be left with is ACY minus BCX. This will be equal to BCX minus ABZ. And this will be equal to again ABZ minus ACY. So can everyone see here that BCX and BCX is coming over here? ABZ and ABZ is visible over here. And ACY and ACY are over here. All these terms are like sort of symmetric. When you add them all up, you get 0 over here when you add them. And over here, you get alpha a square plus b square plus c square. Now, a sum of squares times a number is equal to 0. This obviously cannot be equal to 0, because if it was equal to 0, then all A, B, C have to be 0. But A, B, C appear in the denominator over here. So that's why they can't be 0 by definition. Right. So alpha equal to 0.
So
We
A
have either
squared plus B squared plus C squared is equal to 0.
A square plus B square plus C square equal to 0, or alpha equal to 0. But this is not possible. Not possible. Okay. So what we are left with is alpha equal to 0. If alpha is indeed equal to 0, then ay minus bx, all of these terms, these individual terms will be equal to 0. And ay minus bx is the same as this thing. Cx minus az equal to 0 is this thing. Okay. And then this last term is pointing to this. You just cross multiply, instead of cross multiplying, you take them to the denominator and you'll see that this is the case. Okay. 15 is really easy. I'll do it right over here only. You need to compare coefficients. This will be what? X square minus 2 plus b of x plus 2b. Now by comparing coefficients, I have c is equal to minus 2 plus b. And another equation that I have is 2b equal to c. Okay. 2b equal to 6. Sorry. From here, it is very easy to see that b equal to 3 and then c equal to minus 5. And the answer is done. Okay. C we have found. And finally, this question. Px is equal to P of x. I'll do it in red. Px is equal to P of x plus 3 by 2. Or we can say that this is the same as P of x plus 1.5. So whatever value, so in case you don't know what this notation is, this is saying that you give me some number, I'll give you output some other number. Okay, this is what we call a function. And whatever number you give as x, I will give the same answer when you give me x plus 3 by 2. So now it is given that P of phi is 2013. So P of phi, phi will be equal to P of phi plus 1.5, which is equal to actually what? P of 6.5. Correct. And this P of 6.5 will be equal to P of 6.5 plus 1.5, which is equal to P of 8. So in over here, we have a polynomial or a function basically that is periodic and has a period of at least 3 by 2. So after 3 also it will give the same value. So it's like we are on this number line. 5 will give the same value. 5 plus 3 by 2 will give same value. 5 plus 3 by 2 plus 3 by 2 will also give the same value. So it's like we're jumping from one equal value to the other equal value. So P of 8 will be equal to 2013. Okay, these were last classes questions that I have.
Excuse me, sir. Excuse
Yeah,
me, sir.
yeah,
So
tell
the
me.
value of C will be 5, right? It will not be minus 5.
Yeah, you are correct. This I will use for different. So all of these are positive over here, na? So it will be fine. Perfect. Okay, fine. No other doubts, no?
No, sir. Thank you.
Okay,
So I
we'll
didn't
do some.
understand question 16. I haven't done this before.
Okay. This was given in last class as a homework. So it's no problem if you don't completely understand it. It's just a notation that you are being introduced to. So this notation where you put a alphabet over here and then a bracket, then another alphabet inside. This is called a function. This is the input. Okay. And this is the output that you get. I mean, it could be a number that comes
So
outside, but
then
here we
shouldn't
are
P of I be equal to 6.5?
P of 5 is equal to P of 6.5. And then P of 6.5 is equal to P of 8. So because A equal to B equal to C, A equal to C. Got it?
Yes, sir, but
This is the one here.
why is the uh, if why is P of 5 equal to 2023?
That is given in the question. It's an if P of 5 is equal to 2023. This is just given in the question. So you need to, given this condition, you need to find P of 8. Now, if you want to dwell deeper
So,
into
but
this,
that does not follow the previous like function given that it should be the number
no, no,
given
it
plus
doesn't
1.
violate this. This doesn't violate this. This is relating to so okay, if you graph such a function, okay, if you graph such a function with something like this. So every 3.5, it's coming back to the same value. I just made it very long over here. Let's call this some x. This is x plus 3 by 2. Okay. It's coming back to that same level after every 3 by 2.
Okay.
Got it? This is what a sine curve or a like sinusoidal variation curve or basically any periodic function will look like. But the other stuff given in the question which I have not put for and not added in this question to not confuse you is p of x is a polynomial. Polynomials cannot be like this. Polynomials do not infinitely oscillate. Okay, polynomials either like explode to infinities at some point or are constant. So if it is given that it's a polynomial, it's actually a constant function. The value is always 2030 for every value x. You can dwell deeper into this, think about it, and search more about why polynomials cannot
So what's the
oscillate in
answer?
time. Answer 2023.
Okay.
It's the same. P of 5 is P of 8 and everything. Okay. We'll do some number theory questions.
Sir, in the actual test, will the questions be multiple choice or like filling or
There'll be
like?
multiple choice. You get 5 options. But
Okay.
for while we are learning, I don't give options because that restricts your learning.
Okay.
While doing mock test, you use options and solve it. Okay. Find find question one. Find last 2 digits of 6 to the power 2002. Okay, those who get the answer, just raise your hand. After 2 minutes, I'll give the answer. The hint over here is try to make a list of what the powers of 6 turn out to be, the last 2 digits for each power. So write 6 to the power 0, then 6 to the power 1, then 6 to the power 2, and so on. Okay, you have chat option also. No? Yeah, correct. Riyansh, correct answer. Yeah, Abhiraj and Dakshal, correct answer. Okay, there's an easy way to solve this question. I'll show you. Okay, this is I'll write what is 6 to the power n last digits, last 2 digits. Okay, and this is here side I'll write n. So n equal to 1, we have 0, 6. Then for 2 we have 36. And for 3 we have 6 cube as what? 216, right? So I have 1 6.
216.
So, okay. And then 4, I don't need to multiply, but I know 6 to the power 4 is what? 1296. This I know. But you didn't actually need to multiply this. You can write 96 over here. Now to find next number, just multiply 96 by 6. In fact, you actually don't need to do that if you found the pattern over here. What is happening over here? 3, then you are getting 1. 1 after that you are
It's
getting 9. So
increasing by
every
8.
time it's decreasing by 2 or increasing by 8 every next number, right?
But
So
it's
5
increasing by 8
will be,
only. But
it's
you just don't
increasing by 8
count
or
the.
decreasing by 2, something like that.
No, it's increasing by 8, but you don't count the next uh, power of 10.
Yeah, that's what I'm saying. No? So the next will be 56. You can check for yourself. 96 multiplied by 6, the last two digits you'll get is 76 only. Okay. And then 56, then seventh number will be 36. You see now 36 has come back again. And this number has no memory of anything that was ahead of here. All of the thousands digit, 10,000 digit are all immaterial, or hundreds digit is immaterial when you are wanting to find the next number. Because 36 times 6, you try and see, you will find that it is 216, forget the 2, you are left with 16. This pattern will again repeat. 36, 16, then 96, 76, then keep going on like this. We find again that this has a periodicity of how much? 5 numbers.
Six.
1, 2,
Five.
3, 4, 5.
Six.
Not 6.
Five.
Always remember the periodicity is from the first instance where you find the like a pattern repeating. 06 never appears again. Okay. And that is obvious because you can't have 1 as being 56 now. 6 to the power 1 is not
Oh.
56. Okay. So that way, don't do a mistake. And then find where the first time the repeat happens. And then what you do is you divide 2002 by 5 because it has a periodicity of 5 na? Now we just need the remainder of what happens at 5. Notice what
2.
happens at 2 happens at 7. The same thing will happen at 12 and it will keep going on like that. Okay. So 2002 divided by 5 remainder is equal to 2. So go at the second position. Sorry. Go at the second position and check if that is part of the repeating sequence. Okay. Suppose I had asked in the question 2001. Okay. Instead of 2002, I had given 2001 as the option. You would get remainder as 1. But notice that the first number was not part of a repeating sequence. So we'll defer to what? We'll defer to 6 because
56.
6 has also the same remainder as 2001 when divided by 5. Okay. This is just an extra point that I'm saying, which you should remember for the next question because I'll give such tricky questions also. Okay. So this is 2002 only and remainder is 2. We go to the second place. The answer is 36. Okay. I hope no one has doubt over here. Okay.
Sir?
Now do find last two digits of.
Hello, sir.
Yeah.
Sir, I joined just now. Sir, when is the exam going to be?
Exam is in sometime in January. I don't remember the exact date. It's quite far away. So, but today we are doing number 12. So do this question. Find last two digits of 7 to the power 2005. Now everyone who uh, saw the previous solution, try listing in the same manner. You need last two digits only.
Sir?
So yeah.
Sir, have you shared these questions in any PDF?
No, I'm not sure. I'm just giving it like this.
Sir, I've joined just now. When did the class start?
6:30.
Yes, sir.
Good, Riyansh. Correct answer. Anshu, correct.
Sir, can we use a calculator in the exam?
Nah. See, even if you can use calculator, which I'm not sure about, these type of questions are not supposed to be done using calculator. I mean, you can't use calculator to find the answer of these type of
No,
questions.
like for example, I need to do the multiplication again and again to find the last two digits, no first. For that,
Okay.
we will
It's always a good practice to do it in your head and get it fast. Yeah, Riyansh, correct answer. Vihan, correct. Uh, yeah, these questions are not that hard to do multiplication in your head. Okay, and fast solve this. Uh, our first number is 07 because we start with 7 and then 49, 343. But we don't really care about the hundreds place. So I'll just put it outside this line. Next number is 2401. Sorry, 2401. It's also good practice to remember your powers of small numbers. Okay. And 2401. Whenever you notice 01, the next number is going to be 07. Okay. Whenever you reach a periodicity somewhere and you reach the number 1 again, it is the same as 7 to the power 0, which is also 0, 1. Correct. So our periodicity starts with the number 0 and ends at number 3. Okay, so if I write n over here, n equal to 0, 1, 2, 3, and back at 4, we are at 0. So we find that our periodicity is 1, 2, 3, 4, and 2005, 2005 upon 4, remainder is equal to 1. Now you can go and check where n equal to 1 arrives.
So
Because
shouldn't the
2000,
periodicity be 5 difference between 07 and 07?
07 and 07 also will be the same thing. Okay, if that is confusing, notice here. Start of 07 and before 07. You have 4 only, na?
Okay.
Correct. So now 2005 will be same as 2001, will be same as 997, and so
It's
on
the
until we
number
reach
of jumps.
1. What are you saying?
It's the number of jumps
30
between
PM
the two.
onwards அவ்வளவுதான்.
I don't understand number of jumps. But
ஸ்டோர் ஆயிட்டு இருக்குமா உனக்கு எப்படி உனக்கு தெரியும் இது ஸ்டோர் ஆயிருக்கான்னு டேய் ஒரு
okay,
திடீர்னு
okay,
வெளியே வந்துட்டேன்னா
fine.
ஆட்டோ
So you get answer
ஆஃப்
1.
பண்ணிட்டேன்னா எப்படி தெரியும்
Probably we are saying the same thing. Okay, but you get answer 05.
டேய்
Okay,
எனக்கு
you if you are not
Sir,
directly
what
mute
if
yourself.
it what if the power divides exactly?
Power divides exactly means you get 0.
Uh,
So you would go with the 0 option or you'll go with the 4 option. Whichever is part of our periodic series, that option you will go with. Okay.
oh, okay,
Like I had
sir.
given an example over here 6. Na? 06 is not part of our periodicity. Even before this one option n equal to 0, we'll get 0, 1. 0, 1 we find never in our sequence. Na? So you'll go back to the term that was part of our periodicity. These two are not part of our periodicity, so we won't give them as the answer. Because in
Oh, okay.
essence, 2002 will be same as 2000 or 1998. No, here periodicity 5, no? So 1997. One, correct? That way.
Okay.
Again, I'm not introducing the term modulus, but that is what we are applying over here. Modulo arithmetic is what we are doing, but I'm doing it in a basic manner.
Sure.
2012, find last 3 digits. Abhiraj, try again.
Sir?
Yeah.
Sir, for the last one, I did not understand after the loop, how did it come back to 1?
Also, 343 times 7 is equal to 7 to the power 4, and 7 to the power 4 is equal to 2401. This I wrote from memory, but you can try multiplying 43 times 7, which is 21, and then 7 times 4 is 28. So you get 30. Right? The 01 comes from there.
Sir, what was the question again? Can you?
Yes, sir.
Thank you.
Aryan's correct answer. Vihan, you did the same mistake. Just check what I did for the last question, whatever I said for the last questions. See which number is coming in the periodicity. Anshu and Vihan again try again. Yeah, Vihan try again. Now correct Anshu.
Sir, could you explain again if the power is exactly divisible by the number, then
So is mine correct?
So instead of going to 0, you go to the next one. See, go to whichever number is part of the periodicity. Like I'll show you again in question number this one, question 3.
okay.
Okay, should I start solving? Okay. Here we have, I'll just write down n and 5 to the power n. Last three digits we want, na? We want last three digits. So, sorry, n equal to 1, it is 005. Then for 2, it is 025. 3, 125. 4 is 625. 5 is 3125. So I'll remove 3. 6 will be again uh 56125.
625.
15625. So I'll remove 1 5. And then seventh will be again, you see 625 becomes 125. So 125, 625. And after that, uh, this jump is the same as this next jump. 625 will lead to again 125. Because if once 625 is given 125, always it will give 625 to 125. And the periodicity becomes 2.
So the
Okay.
number of jumps is 2, so the periodicity is 2.
So just see over here that what is part of our periodicity? 125 and 625. When did we first see 125? Here. And when did we first see the second time appearance of 125? Right there. Okay. So this is where our periodicity starts. 0, 1, and 2 are not part of our periodic chain. Okay. So when we have been asked to find 2, 0, 1, 2, you divide it by 2, you get remainder equal to 0. 1 second. 2012, you divide by 2, you get remainder equal to 0. But you don't go to the n equal to 0 term. You check the next one. Is 2 working? No, because this is not part of the periodic chain, not part of the periodic chain. This is 001. You go to the first number where the periodicity actually begins. Your answer will not be 001, will not be 025. Answer will be 625.
So shouldn't answer be 125?
Yes, sir.
Did I make a mistake? No, no, no.
25.
Don't go where the periodicity is starting. See, uh, 1 second, 1 second. Yeah, so like I was explaining, 625, 2012 will be the same as 2010, will be the same as every even number. Correct? So it will be the same as 4, will be the same as 6, and the same as 2, supposedly same as 2, but but because 2 is not part of the periodicity, we'll get answer 625.
So can we like eliminate the first two elements of the periodicity by subtracting 2 from the power?
No, no, you don't need to subtract 2 from the power. See, subtracting 2 from the power will lead to only 2010. No? That is what I'm saying.
Yes.
Whatever answer is of 2012, last three digits will be the same as last three digits of 2010. The chain will keep going on until you reach 4. But since 4 is obviously not equal to 2 over here, we'll stop our search at 4. Because we know what is for 4, we know what is for 6, we know for every even number after 4. But for before 4, we are sure that it is not the same. Okay, fine. We'll do another question. Find the trailing zeros in 30 factorial, and 30 factorial is equal to 30 times 29 times 28 times 27 dot 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 until you reach 5 times 4 times 3 times 2. Okay, in case you are finding it difficult to do this question, try finding 5 factorial, 6 factorial, 7 factorial. Okay, and 4 factorial. Look at what is happening when you are calculating 4 factorial, 5 factorial, 6 factorial, 7 factorial, and then find the answer.
Excuse me, sir. Sir,
Yeah.
is there a WhatsApp group for this?
No, as far as I know, there is not a group.
Sir, how
In fact,
do
this is probably the last class because we have already completed the syllabus. If there will be further classes, you will of course be intimated about it. Uh, but our syllabus is almost all, I mean, it's over. I'm just redoing number system part in a slightly different manner.
okay, sir.
Fine, Riyansh, yeah, your answer is correct. Anshu, correct. Vihan, try again. You have found six numbers divisible by pi, correct, but one of those numbers
Sir,
gives 5 twice. Check it.
Sir, what does it mean find the trailing zeros?
So if you have a number uh, 5040, the trailing zero is this. This is not a trailing zero. Okay. So a number like 72000, this has three trailing zeros. Okay. Krishna, Krishe, try again. Abhiraj, try again. Atharva, try again. Kuman, try again. Abhiraj, no, it obviously it will come na. You just check. See, 4 factorial is 4 times 3 times 2 times 1, and that is equal to 24. 5 factorial is 24 times 5, so 125. 120, sorry. 6 factorial is 720, and 7 factorial is 5040. Okay, so notice a pattern over here and try solving the question.
sir,
Yeah.
sir, I was actually absent for all the previous classes. Sir, can you tell where the recording is saved?
So I don't think, I mean, I don't have access to the recordings. Although their classes were recorded, I'm not sure they are accessible to anyone. But all the same, yeah, you try contacting the transition lab preparatory school. They probably are the ones
Sir,
who
can
have
you
access to.
give their
So I tried again. Can you check it?
Now, first we'll do question discussion. After the end of the class, we'll discuss all of this technical stuff. Okay. So notice over here that 30 factorial is a bunch of 2's, 2 to the power a times 3 to the power b times 5 to the power c times 7 to the power d and so on. This is what is called the fundamental theorem of arithmetic that says that every number has a unique prime factorization, and this is what we call a prime factorization. Okay. Now, what does trailing zero imply? Trailing zero means if I have a number 72000, this means this can be written as something which is not divisible by 5. A. 10 does not divide A multiplied by 10 to the power x, where x is some integer. Okay. This another way I mean is 10 is not a factor of A. Now A itself will have a prime factorization of its on its own, correct? So for this number 72000, I'll do the prime factorization and give an example. This will be 2 to the power 1, 2, 3, 4, 5, 6, 6 times 3 square times 5 cube. Notice that we have 2's power more than 5's power, and that is all that matters. The power of 3
The
doesn't
number
matter.
of common
Yeah. The
factors
number of times
just
2
2
and
and
3 are
5
coming. Yeah.
multiply. 2
Yeah.
and
Whichever
5.
of these is minimum, that will come. We'll remove that many 2 and 5 together common. So that will be 2 to the power 3 times 3 to the power 2 times 2 to the power 3 times 5 to the power 3. And this will become 1000. This is what is contributing to our trailing zeros. Because in our decimal system of numeration, whenever we multiply by 10, it's equivalent to adding a 0 to the rightmost digit of our number. So, in the same spirit, all we have to do is for 30 factorial, we need to calculate the power of 5 Because we know for sure, look over here. This already has lots of powers of 2. 120, when the first time 5 came, it has lots of powers of 2 also. 720 also has lots of powers of 2 when we remove this 0. 5040 also has lots of powers of 2. Okay, so we don't really need to worry about how many power of 2s we have. All we need to calculate is the power of 5. This I've just said in a very uh, hand wavy manner, but you can actually prove that how much ever large this factorial becomes, the power of 5s in it will be much smaller than the power of 2s in it. Okay, and from this we can write that 30 factorial has 30, 25, 20, 15, 10 and 5. These are the numbers that are contributing 5 to our number 30 factorial. All right. Although this number is contributing 2s also, and this number is contributing 3, we don't really care. How many 5s they contribute is what is of importance. Okay. So 30 is contributing 1 5. This is contributing 5 square. Here 5 is coming, here 5 is coming, another 5, another 5. So in total, if I want to count it, is 1, 2, 3, 4, 5, 6, 7. Okay, so our answer will be 7 because there are 7 powers of 5. We can be sure that there are 7 powers of 5, even as low as 8. Because 2, then 4 gives 2, then 6 gives another 1, and then 8 gives another 3. So as low as 8 factorial, we are sure that 2 gives to power of 2, we have 7 at least. So till the time we reach 30, we have lots more powers of 2.
So
Okay.
number of
So
powers of 5, since that will be less than the powers of 2, obviously.
yeah. So
So we should
that is
just,
what we only powers of 5 is required to calculate.
so every 5 the number of
Yeah. So that is what I'll
yes.
give a larger number. Now notice what is happening. 5 also, you divide 30 by 5. What do you find? You get answer as 6. Notice that we have 6 such numbers. 6 such numbers. 1, 2, 3, 4, 5, 6. We have 6 such numbers that are divisible by 5 up till 30. How did I find that? I divided 30 by 5 and wrote the quotient over here. Now, how many numbers are there that are divisible by both 5 and 5 square? I mean, the number which is divisible by 5 square itself is divisible by 5. Na? And that number appears every once in 5 times for these powers. Notice, I'll just write down the powers of 5 like this. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Notice that after every 5 intervals, you are getting powers of 5 that are uh, like divisible by 25. And when you keep continuing this, every 5 times these appear, you will have 125. And then every 5 times 125 appears, you will have 625. Okay, are you getting what I'm trying to say? So to do a fast way to find our what do you call number of trailing zeros or number of times 5 is divisible by the number of powers of 5 that we get in our number, all you have to do is take 30 divided by 5, whatever you get 6, store it somewhere. Okay, then take 6 divided by 5, get 1. Only quotient counting you have to do. Don't go after the remainder or the decimal point. Okay, that's why I put an arrow. Okay, 6 and then plus 1. This will be your answer. This is a short trick to do it. You can prove it on your own also. Okay. And if you are very much
So you have to
interested,
do it.
this is no. This I'm
So
just
you have to
giving
do
as a
it
trick until you get 0. So 1 divided by 5 will give 0. So you add 0. It's the same thing as doing nothing. Correct. So the trick over here is this plus 30 upon 25 plus 30 upon 125 and so on. This weird kind of bracket, this
Greatest integer function.
is greatest integer function. So in case you don't know what greatest integer function is, leave it. It's of no concern right now or to whatever I'm teaching. But it is the greatest integer less than or equal to the number. Again, just pay attention at the definition. you'll always find the answer correctly. Okay. And whatever I'm saying over here is just is same as taking quotient. Okay. If you have something divided by another thing, whatever quotient you have remaining, that is your greatest integer function
What?
over here. Okay. I'll not complicate stuff because it gets confusing very fast. Okay. Try question 5 using the same method that I've written on top of it. Question 5 is trailing zeros of 135 factorial.
Is my answer correct?
Just a second.
Sir, is my answer correct?
Just a second. Okay, here. I thought I had the answer. With me. 1 second. Correct. Okay, don't spam, Dakshal, don't spam. I can see it once. Abir, try again. Vihan, correct answer. Shamika, correct. Anshu, try again. Probably you did some typo. Yeah, Riyansh, correct. Anshu, try again. Riyansh, correct. Abhiraj, not correct answer. Try again. Okay. Now, since I've given you already the formula, 135 divided by 5 will be equal to 27. Keep the 27 aside. Okay. Then 27 divided by 5, you get 5 because 5 is the quotient, 25. So add 5 over here. And then 5 divided by 5, you get 1. 1 divided by 5, you get 0. As soon as you get 0, stop. So 27 plus 5 plus 1 is 33.
So your screen is frozen.
Oh, I'm sorry. Stop. Say 1 second. Okay. So I'll just repeat what I said right now. 135 divided by 5 is 27. And then 27 divided by 5, I keep this 27 aside. Okay. And then divide by 5. So I get 5 again. Okay. 5 divided by 5. Again, I get a 1. So 27, 5 and 1. I add up to get 33. I hope that is clear.
Sir, I got 32.
So 27 plus 5 plus 1, check now. This arithmetic of mine is correct. See wherever
No, I
you.
don't get this method. Cause like
Okay, what did you do?
I did like 5 plus 5 cause 10 is also a multiple of 5. 15, so that's 5 again.
So this
Plus
method of counting will end up somewhere giving some error. Because just see, it's like you have this long list of numbers that are divisible by 5. Every fifth number, you have 25, 25, 25 or 50,
yeah.
75, 100, 125. So this is the 5 that are coming to. Okay. And then 125 has 3 5s. So it has double circle around it. So this is that extra 1 that is coming. Okay. For 125, only see
Oh.
when we were counting for 5 power numbers that are divisible by 5, we counted 125 once.
Oh.
When counting for
It's
25, we
cube.
counted it again. And for
It's
125,
cube.
again we have to. Yeah, it's cube. Okay, but that's why this formula works. This formula not only works for 5, it works for all numbers. So you want powers of 2, calculate that. Do that. Next question is calculate powers of 2. In 30 factorial equal to 2 to the power a times 3 to the power b times 5 to the power C times 7 to the power D times not 9, 11 to the power E, 13 to the power F, 17 to the power G, 19 to the power H. It's obvious now after what do you call 17, 19, 23, and 29. All of these are power 1. Okay, 13, I'll just tell you our answer is 2. Find A, comma, B, comma, C, comma, D, comma, E. C we have already found. You just need to find A, B, C, and E. I mean A, B, D, and E. Okay, someone got the answer. Riyansh, your answer is correct. Yeah, correct. Dakshal, A is correct. I'll start solving it. Meanwhile, if everyone gets the answer, just put it on the chat or just cross check. Okay. 30 divided by 2 so is 15. I'll keep 15 aside. 15 divided by 2 is 7. So I'll keep 7 aside. 7 divided by 2 is 3. I'll keep 3 aside. 3 by 2 is 1. And I'll stop myself over here. This is 26. So A is 26. Then 30 divided by 3 is 10. So I'll keep 10 aside. 10 divided by 3, 3. So I'll keep 3 aside. 3 divided by 3, so 1. From here I get 14. C we had already calculated as how much? 7, no? C was 7. Recall from previous question number 4. D will be 30 divided by 7, so 4. 4 then 0. So I have only 4. And then E is for power 11. So 11 divided by 30 will be 2. I'm left with 2. So this is my answer. Whoever got answer as this answer, very good. Whoever could not, this is the method to do it. Okay.
But sir,
Now,
using this method, you only find the number of trailing zeros. How can you figure out whether this is the power of that number?
no. So for trailing zeros, what did we do? We found the power of 5 because again we broke the question down into different chunks. First, the question was finding trailing zeros. We found that trailing zeros is equivalent to finding the power of 10, and power of 10 is finding the maximum power of 5. So each step is bringing us down to finding this. The final step was finding the value of C to find the trailing zeros. Now, from the what do you call theory of how we can find the power of 5, we have actually prime factorized 30 factorial without actually writing down all the entire 30 factorial. Correct. And we have also do not have to multiply out the entire 30 factorial. See, the another same thing would be to actually write down 1 times 2 times 3 times 4, and then for each number cancel and just do tally marks for each number. So 2 I have found 2 over here, another 2 over here, then you get 5. So for 5 you put a tally mark. That is a very what do you call primitive way of doing this uh, prime factorization calculation. Okay.
Okay, sir.
Now I'll come to the actual question that I was like stepping up to. We will actually solve a very tough question, which on its own seems like very daunting to solve. But just look at this. Find the first non-zero number, non-zero number from, so it's from the right. Okay. So what do I mean non-zero number? If I have a number of this form dot 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 a and then 0 0 0 0 0. So you need to find this a, whatever that is. Okay, this is equal to 30 factorial. You need to find a in the decimal expansion of 30 factorial. Okay, use all of the question or the knowledge of all the questions so far. I'll keep this series in front of you. Use it to solve this question. Okay, Abhiraj has got an answer. I'll just check. No, answer is not correct. Yeah, yeah, correct answer. Okay, so this will be one of the last questions. I'll do another few questions also. Okay, I'll give a hint of how to go about solving this. First of all, we'll write 30 factorial equal to 2 to the power 26 times 3 to the power 14 times 5 to the power 7 times 7 to the power 4 times 11 to the power 2, 13 to the power 2, 17 to the power 1, 19 to the power 17, 19, then 23, and then 29. Okay, now we noticed what? We want the last digit. So we'll remove 2 to the 5 to the power 7, and from here 2 to the power 7 we'll remove. Okay, we are dividing by 5 to the power 7 and 2 to the power 7 to remove all the powers of 10. Okay, Dakshal, not correct answer. Anshu, not correct. Try again. Okay, why did I do this division by 10? Because I want to get rid of all the numbers that were power of 2 and 5, but not all powers of 2. Okay, all powers of 2 are not contributing to the 0.
Just the powers of 10.
Just the powers of 10, we need to remove them. So 2 to the power 7, 5 to the power 7 is gone. So our truncated expression 330 factorial divided by 10 to the power 7 will be 2 to the power, I will not write the entire thing, 2 to the power 19, 3 to the power 14, 5 to the power 0, because we can't have any powers of 5 with 2 to the powers of 2 with us. It will always lead to a 0 at the end. Okay. And then 7 to the power 4, and then I'll do one thing. Since I have copy this. Paste. Okay. Correct. Now I'll find 2 to the power 9. I'll find last digit of all of this through the same method I used to find the last digit or second last digit of these powers. Right? I'll use the same technique again and again, like we did in the question 1, question 2, and question 3. The same technique I'm going to use to find last digit. 2 to the power 19 I can split into 2 to the power 9 times 2 to the power 10, and 2 to the power 9 as 2, and 2 to the power 10 as 4, because 5 and 2. Okay, and 1024. So this will be 8. Okay, we'll keep 8 aside. Then 3 to the power 14 This will be 3, this series will be 3, 9, 27. And after 27, 81. So we are at 1 back again. So 14 divided by 2 divided by 4, sorry, will give remainder 2. And for power of 2 will be 9. So 8 multiplied by 9 I'll give. Got it? This is giving 2 to the power 19 is giving 8. 5 to the power 0 will give 1 multiplied by 1. And then 7 to the power 4, again, just remember this 2041, no, 2401. So 7 will also give 1. 11 will give 1 as default because 11 to the power 2 is 121, so it will be 1 again. 13 square is 169, so it will give 9. Okay, 17 will give 7, 19 will give 9, 23 will give 3, and 29 will give 9. Okay, now all these nines, we have too many nines over here. No? 9, 9, 9, 9. Okay, these nines are 9 to the power 4. We know that 9 goes as 9, 81. Once we have 1 again, 729 again 9. So 9 we have power 4. So 4 divided by 2, remainder is 0. We'll go to the power 2, which was 81. So all these nines together become 1. Okay. We are left with 8 multiplied by 1 multiplied by all the ones I can forget. 7 multiplied by 3. 7 multiplied by 3 is 21. Okay. So 21 and 1 will not affect 8. So our answer will be 8. Okay. So our entire calculation was this. Now there is no easy way to calculate the second last digit after the trailing zeros. So that's why it's not a question. Fine. Just look at this stuff that I've done. If you don't understand it, we can discuss it again. Class is over, but I can give some questions as homework. Okay, just a second. Okay, do these questions. These you can take as homework questions. I'm not sure if we will have another class next week, but if we do, we'll discuss them shortly. Okay. These are some questions from very old AMC papers. It was not called AMC back then. Yeah, I'm sure. I'm not sure about that. If it is true, if classes will keep continuing, I'll be taking the classes and we'll discuss these questions. Okay. So today's class is over. Now the back to the technical stuff. If you does anyone have any technical issues that needs to be solved?
Sir, how will we understand if the next class is going to be conducted or not?
The same way you got some message somewhere. Now you got the same way you got access to this link. The
Yes, sir.
same place you'll get a link. How do you get access to this link and this?
Sir, we get a email.
So if you will get email, then log in through that email. If you don't get email, then probably classes are over. Okay. Well, I have completed the syllabus. I'll just do some revision questions and stuff like that in the next classes. Okay.
Sir,
Yeah. Any doubts? Then I can solve them right now.
sir,
Tell
can
me.
you give the contact number to whom which I can contact to get the recording of the classes?
Um. Actually, I am also not aware of that. So, probably the recordings. See, I also don't have access to those recordings, the classes that I have given. But you can have a discussion with the host. But fortunately, they are not online. See, by next class, I'll give you a definite answer about whether you can get the recordings or not, because I'm not sure if those recordings are publicly available. These are a one-time class kind of scenario. I guess they are recorded, but they are not for sharing. I guess. Anyways, next class we'll discuss this stuff, and I'll come with some concrete answer for you. Okay. Any other doubts related to maths? Something from number theory that you want to discuss? Okay. And I'll end the class. Actually, I'll leave it. You guys can also leave. How should we prepare for AMC 12? AMC 12, so there is reference material. See, what in my opinion, the previous year questions are the perfect reference for writing any exam, be it any Olympiad, because Olympiad they follow the same kind of question pattern. You just go through the previous year questions if you have access to them. See, in this internet era, you can get access to anything. Just try searching for search it hard enough. You'll find some PDF of it somewhere. Okay, fine. I'll leave them.
Excuse
Bye.
me, sir. Sir,
Yeah, tell
sir,
me.
I'm there for AMC 8. Sir, can you tell how to prepare? What is the syllabus? And
See, syllabus will be available on the website. There are too many topics. I can't list out all of them. But doing the previous year questions will help. Okay, just
sir,
go on MAA website. There they have a few books that you can purchase, or you can search for those same books on internet and probably find a PDF somewhere. Okay, or go to some library in your school. They might have those books. Okay. Previous year questions are the best resource for solving any Olympiad level stuff.
yes, sir. Sir, are there any other reference books?
There is something called Mastering AMC 8. You can search for it. It's very easily available. Mastering AMC 8, Mastering AMC 10, those series of books.
Yes, sir.
Okay, fine. I'll end the class. Bye, guys. Able to leave.
Thank you. Thank you, sir.